Assalamualaikum and hi to Puan Rosie. We are going to present about engineering design DJJ40173. The title of our presentation is Application of Reverse Engineering in the Medical Industry. We are from DKM4B. I am HAFIZAH binti DAWI and my group members are OWEN RAPHAEL, XAVIER NIKO PRITCARD, Muhammad YUSRI and ALVENZEPRESLE. Our presentation contains introduction, process and device, mechanism that makes the device work, material used and suggested improvement, conclusion and reference.
Reverse engineering is the method obtaining three-dimensional data in computerized form from physical model or product. It has clear benefit of effective use together with additive technology and vacuum casting in silicon mold. 3D printing, also known as additive manufacturing technology, create the object layer by layer. 3D printer can produce more complicated shapes than traditional manufacturing techniques. Currently, 3D printing involves area manufacture of individual surgical templates, fabrication of individual surgical implant and prosthesis, spinal implant, manufacturing and variety of orthopedic and prosthetic construction in dentistry. Complex geometry from the medical instrument complicates the process of measuring of the control size and determining of the exact geometry. Tweezers used in microsurgery of the eye are subject to frequent changes in design appearance. On the one hand, the simplicity of the tools; on the other hand, complexity of the geometry of the handle of sticking has necessitated of the use of reverse engineering. Therefore, the aim of this work was explore the possibility of reverse engineering in this example, the speed of obtaining a product prototype.
Each layer is stretched by a laser beam according to the program. Laser interaction lead to a polymerization of the material at the point of passage of the laser beam. After printing is complete, the product is washed to remove the liquid photopolymer and is processed to the ultraviolet chamber. Stereolithography requires the use of support structure for the extraction of high-angle component of the model. Support are generated in the MAGIC program and are made for the same photopolymer material. Support elements are temporary construction elements which are removed manually after the complete of the manufacturing process. Acetting technology allows applying fiber with a thickness of 15 microns, which is several times smaller than the thickness of the human hair. The total manufacturing time of tweezers was 2 hours. First stage should be to clean up the cloud of points obtained from the scanner, remove excess geometry and reduce the spread of points from the average value. Tool match doctor, remove all the defects in the automatic mode. After we connect missed element, scan and build surface on the unscanned area. Also at this stage, it is possible to change the number of polygons and their distribution. By optimizing the model, what will reduce its size. The total model processing time was 12 hours. SLR technology has been selected for printing. This method is based on laser indirection of the liquid photopolymer resin for creating solid physical models. Construction of the model is produced by layer upon layer. A perfect surface of scanning, volumetric, white, matte, and without tight space and sharp edge. 3D scanner captures still various noise. This can be characteristics of the object and the external condition of the characteristics of the scanner. Eventually, unnecessary roughness, tunnel, and holes and other artifacts are formed. The resulting surface of the object can be viewed in different ways, as a cloud of point or mesh. In the second case, all the points are connected into triangle which form a million microsurface. This grid is a complete polygonal model. It can be saved in STL format or other format.
Mechanisms that make the device work. For the analysis of tweezer scanning features, 3D scanners were selected. Firstly, solution NIKO RegScan 450 MP. Second, Smart Optics Activity at 150, and the last one is Artec Spider. Artec Spider is the professional 3D manual scanner. The device uses an LED backlight in combination with 4 cameras 1.3 MP resolution. Scan rate up to 7.5 frames or 1 million measurements per second. The accuracy of scanning 0.05 millimeter. Smart Optics Activity at 175 is a desktop optical 3D scanner with enhanced performance. The device is designed to produce high-precision digital models. The scanner has a high resolution which reaches 0.01 mm. The scanning process is fully automated and takes about 1 or 3 minutes. Depending on the size of the object, the obtained data are exported as STL file. The next RegScan 450 megapixel is a professional 3D scanner that creates highly accurate 3-dimensional models of real objects with a resolution of 5 megapixels. The device works on the contactless method of the optical path triangulation of obstructed white lights. Variable angle of triangulation and adjustable scanning area provide an opportunity to obtain scans accuracy of 0.01 millimeter.
Okay, now moving on towards material use and suggest improvement in terms of medical application on reverse engineering. Now, there are a variety of material use in terms of medical application in 3D printing, and some of those are titanium and nylon. Now, titanium is a much more sustained material than steel and aluminium, and is much more eco-friendly towards the environment, while nylon is much more sustained than plastic and is cheaper, but is not biodegradable, which means it will pollute the environment. Now, moving on to the production speed of both this material, titanium will usually take much more longer time to produce the 3D printing, as it is a much more better quality material than nylon, while nylon will more likely produce it faster than titanium, as it is more cheaper and easily obtained. In terms of production, the production of prototype that both this material produce usually have already been made and undergo desired modification, which means that customers or consumers will more likely choose something that is faster and cheaper, which is nylon.
Conclusion: as a result of the work ophthalmic tweezer for microsurgery or scanned virtual model with a new design was created. Prototype of tweezer obtained at the slide installation project 6000. The use of reverse engineering and additive technology has reduced new product development of up to 6 hours instead of 2 weeks. Okay, this is the reference we obtained. So that's all from our group. Thank you.